The majority viewpoint among researchers believes that current models continue reading about the universe's beginnings to serve as the primary justification for the beginning of the universe. This fundamental theory explains how stars, additionally, planetary systems emerged, a progression that eventually brought forth life forms, including human beings. Although the name may seem strange, the idea of the Big Bang presents a rich narrative about the possible occurrences that defined the universe's very beginning. Initially, everything in the universe's energy were concentrated in a remarkably insignificant point, significantly tinier than the pin's head, where the particles were tightly encapsulated. From this high-density origin, an enormous outburst of energy and matter, commonly referred to as the Big Bang, took place. This immense eruption that took place over billions of years ago started the ever-expanding journey through the universe. Yet, as human comprehension of astrophysics and cosmology broadens and the conventional Big Bang framework begins to emerge, bringing about new challenges to long-standing assumptions. With the James Webb Space Telescope's deployment JWST, a highly regarded observatory, sophisticated and substantial space-based instrument ever devised, astronomers anticipated its consolidation support for the Big Bang theory. But, surprisingly, in just 1 year of operation, the telescope's phenomenal ability to see into the far reaches discoveries from the universe revealed that stunned the scientific establishment. Using the telescope's extraordinary vision has brought forth galaxies from a time so long ago, it calls into question previous assumptions and ideas regarding the origin of the universe. This development has resulted in intense debates over whether material might have existed prior to what we currently define as the Big Bang. One of the most pivotal milestones came when cosmologist Rohinatu, combing through data collected using the JWST, identified a galaxy formed not long after the actual Big Bang. This universe is now considered the most remote and oldest ever detected. The repercussions of this find were felt throughout the scientific community, showcasing just how revolutionary the technology of the JWST truly is. The telescope's capacity to transform our understanding of the universe is just getting started, bringing forth, indicating new information about the epoch of the universe's beginnings. Once more, loosely interlinked with pre-existing cosmological ideas, it holds the essential hints as to how the earliest groups of the birth of galaxies and stars. The insights brought forth by the JWST are already clashing with traditional models, which reveal galaxies with scientists had previously hypothesized inconceivable at this early stage. This sudden growth of galaxies in the early universe has sparked a flurry of enthusiasm and deep inquiries from experts, requiring an immediate re-evaluation of current frameworks. As researchers investigate deeper into this new data, they are being asked challenging questions regarding the very fabric of the universe itself and the forces of nature that ruled its early development. Apart from its groundbreaking findings, the JWST's physical location provides it critical advantages. It functions approximately 1.5 million kilometers away from where we live, shielded from interference from the Earth and maintained at frigid temperatures near absolute zero, thanks to a massive sunshield comparable to a tennis court in size. It has a large primary mirror coated in gold and instruments with extreme sensitivity, engineered specifically to peer into corners of the universe that have remained hidden up until this point. The period this telescope is unveiling, often dubbed the Cosmic Dawn, took place about 200 to 300 million years after the Big Bang. The epoch that took place during the first stars, luminous bodies, and galaxies suddenly started to move into existence. However, the mechanisms and circumstances that led to these events, with numerous hypotheses centered on the roles of dark energy, invisible dark matter, and how stars interact, forming gases and interstellar dust. The singular capability of JWST to locate galaxies provides from this crucial juncture cosmologists with a rare opportunity to rigorously test or modify theoretical models. By analyzing the data, they can operate from these distant systems, either verify the robustness of their frameworks or discover contradictions that may lead to paradigm-shifting revelations. At the outset of its mission, JWST expectations were conservative. The scientists agreed it would detect only a modest number of small galaxies in the early universe, but these expectations were rapidly surpassed. The telescope's debut snapshots of the ancient cosmos unveiled a staggering array of galaxies differing in age, number, size, brightness, and characteristics that far surpassed what was anticipated. This file share of early cosmic data has led to an intense scientific competition to define what qualifies as the earliest colossal system throughout the universe. Findings continue to pour in, surprising even the most seasoned astronomers. These ancient galaxies, which were made possible by JWST, ask important questions about our foundational beliefs concerning the universe. While some scientists are optimistic about the possibility of incorporating them into existing cosmological theories, others contend that they represent the initial clues that point to a far more mysterious and layered universe than we ever imagined. The underlying question continues to linger. How did the organized universe we now recognize emerge from the primordial chaos crucible that marked its beginning? The telescope's early findings may dramatically reshape not only the prevailing view of the Big Bang, but also offer fresh interpretations of distant structures in the galaxy, some of which might even alter our understanding of the Milky Way, our own galaxy. As Mark McFadden, a senior leader in science at the European Space Agency, aptly summarized, the purpose of creating instruments like the JWST does more than just confirm established theories. It's meant to test and possibly tear them down. You never know what might happen. He put an emphasis on the idea that the JWST can be traced back to 1985, long before the Hubble Space Telescope took flight. Gard, then science director of the Space Telescope Science Institute (STSCI), was charged with envisioning what might follow in the footsteps of Hubble. Though many were skeptical at the outset, wherein a dedicated team laid the initial foundation for what would eventually become the James Webb Space Telescope. Where Hubble specialized in capturing images in the visible spectrum, the JWST was designed specifically to operate in the infrared spectrum. This choice is vital because light from galaxies far away, as a result of the expansion of the universe, redshifts into the infrared range, rendering it invisible to optical telescopes such as Hubble. The enormous ice-cold mirror of JWST makes it possible to locate these obscure signals, allowing astronomers to break down the universe's layers to a time closer to the origin of the universe than ever before. The essential requirement for such a telescope was made abundantly clear in 1995, when the deep field images taken by Hubble revealed countless galaxies in a seemingly vacant sliver of sky. This eye-opening revelation demonstrated how numerous the early universe was and emphasized the urgent requirement for a telescope with even greater reach. After decades of meticulous planning, growth, and a financial investment totaling around $1 billion, the JWST finally became available on December 25, 2021. It was fully operational by July 2022 and prepared to begin its significant scientific mission. Projects aimed at research, similar to the early Release Sciencers program as well as the General Observation program, were established to hunt for the first galaxies in the universe. Although the initial predictions were cautious, the telescope's first wave of data quickly outperformed them. The JWST observations have already begun to test and, in some cases, overturn established models of the universe's early days. These results serve as a powerful reminder of why stretching the limits of exploration and investing in technologically cutting-edge instruments are so important. With each new batch of data coming through the telescope, researchers are on the verge of potentially rewriting everything we thought we knew about the universe. When the JWST's initial transmissions were made available, anticipation was electric. Researchers who had been preparing analytical tools and models were finally able to put them to use after years of preparation. Rather than adhering to the traditional peer review's slow pace, many researchers chose to publish their findings immediately via preprint platforms like Arxiv, enabling rapid access and instant critique. This method sparked widespread and swift conversation, particularly on social media platforms such as Twitter, where experts could weigh in almost in real time. Rowan Natu, a cosmologist, described this approach as science by press release, an acknowledgement of the speed and visibility of the scientific dialogue that ensued. While this transparency helped accelerate feedback, some scientists expressed concern that it might jeopardize the thoroughness of conventional scientific scrutiny. Lead scientist Klaus Pontoppidan, project scientist for the JWST at STSCI, cautioned that although this high-speed sharing of discoveries enabled rapid cooperation and the sharing of knowledge, it also posed a threat to overwhelm the cautious structure typically used to define the scientific method. The avalanche of major discoveries from such a high-stakes project presented new hurdles for traditional workflows. However, the consensus among researchers remains that these difficulties are worth enduring for the immense knowledge being gained. The Big Bang model is still broadly recognized as the cornerstone explanation for how the universe, including the stars, life itself, and the systems of planets, came to be. Though its name might be misleading, the Big Bang theory lays out a coherent, science-backed narrative about how everything came into existence. At its start, the universe existed as a compact, incomprehensibly dense singularity, smaller than a grain of sand, where particles were crammed together tightly. From this almost dimensionless point, a tremendous eruption of energy and matter occurred, facilitating the extensive development of the universe we currently observe. But as the JWST continues to gaze deeper into the void of time, its discoveries are beginning to expose the limits and gaps within the original concept. The revelations of galaxies forming in an era far too early to correspond with the present timelines suggest that the story of our universe is far from finished. These findings not only challenge the framework of the Big Bang, but also open new means of comprehending the fundamental principles that guide everything from the smallest atomic particles to the most massive galaxy clusters.